Hello everyone, welcome to this video where we're going to be generating some cylindrical geometry, or in this case actually maybe we'll generate some conical geometry using the clone tool in S-Frame. And this is all going to start off by us defining basically a member that will form kind of the shape that we're going to be cloning and rotating. So to do this, I'll start off by clicking on the joint tool, and I'll define a joint along my x-axis here. I'll say that this joint here at x equals 4 meters is going to be my start joint. Just turn on the display of my joints a little so they should appear a little bit more clearly. And then I'm also going to define the coordinates of my other joint here. I'll just click on the coordinate definition. I'll say it's at x equals 2.5 meters and z equals 4 meters. I've entered that in the data bar at the top of the screen, and I'll click OK. So I've got these two joints, and I'm going to connect them with the member. So I'll use the member definition tool, and I'm going to just configure the member type here to be a wall integration line. And this is an important step in this process, as you'll see later on. So left click here, and left click there to end the command. And we can see now we have this line drawn in 3D space. It is not vertical, so this will allow it to form basically a conical shape. And we're going to rotate about the global z-axis. We could rotate about any axis we want. I'm using the global z-axis for this example, so you'll notice here that, again, my member is not in line with that z-axis, so I'm not going to get a cylinder, it's going to be a cone shape. I also want to add this member to my clipboard, so I'm just going to go to the Edit menu, copy. I could also just do Control-C on my keyboard. When I copy it, it turns this maroon color. That's just to indicate to me graphically that it is part of the clipboard. Now with this information defined, let me go to the Clone Multiple Copies of Clipboard Contents tool. You'll notice here it's mentioning the clipboard contents, so everything that's appearing in red. I'm going to right click. It's going to open up a dialog on my other screen. I'll move it over here. And here we have the controls to create clones of this type of information. Now we have another video that discusses this specific tool in more detail. If you're interested in that, you can check it out. Just search for S-Frame Clone Tool. However, I'm going to focus on the generation method for rotation. And you'll notice I have essentially two different options here. I can, first of all, just create specify my first copy increment around basically a rotational degree increment around a specific axis, or I can specify the number of copies I'd like. I'm just going to go with this right-hand side option here, and I'll say I want 18 copies, and I want to rotate about the z-axis. The z-axis is the vertical axis here, at a 20-degree increment. So 18 times 20 is 360 degrees. I also want to configure here, it says extrude surfaces from wall lines. So I drew this member in as a wall integration line. That's what it means by wall line. And I have the option to extrude surfaces either as quadrilateral elements or as panels. Panels can be meshed, or they can represent area load panels or rigid diaphragms or those sorts of things. I'm going to work with the extrude quadrilaterals option, where I specify the number of shells within the longest line. I'll say here, along this line, I'm going to divide it up into 5 shells, and we can choose whatever we like here. And in the number of shells between the largest increment, I'm going to set this equal to 1. You'll notice here I have a 20-degree increment, so basically I have 1 shell for each increment, and the thickness of the shell is going to be 20 millimeters. And when I click OK, we can see what happens. I'll click OK, and we see briefly there it flashed with some information. It looked like a cone, but you'll notice if we draw your attention to the bottom left corner of the screen, I have Hide Unselected Objects turned on right now. So if I just toggle this off, here I can clearly see the cone that it's created. Based off the geometry that I input. So it's rotating this cone about the z-axis, and it's generated along this wall integration lines. If we just count up here, it has 1, 2, 3, 4, 5 shells along that line, and 1 shell through each 20-degree of rotation. And of course, we could have done the same thing if we had a vertical line or a parallel line to our z-axis. It would have just produced a cylinder rather than this cone. So feel free to take a look at this, use it to your own requirements, and let us know if you have any questions.